Hey, Algebra 2A peeps, what's up? This is Mr. Miller coming at you from Clark High School on Friday, September, what is today? The 8th, I think. I don't know, I'm so tired I can't remember what today is. But anyway, I'm here Friday after school and I'm trying to get this video made for you guys. Thank you for taking the time to watch it. What I need you to do is to pause the video and write this stuff down in your notebook. And once you're ready to continue, hit play. All right, so we're still graphing lines. We did slope-intercept form. That's one technique to graph lines. Another technique is to use intercepts. And because we only need a minimum of 2 points to graph any unique line, using intercepts is very convenient because in our equations we have an x and we have a y. We can solve for the x and solve for the y intercepts. That gives us 2 points. We can plot those 2 points, connect them, and we're done graphing that particular line. The x-intercept is going to be where the line, or it could be anything, it could be a parabola or a circle or whatever, is going to cross the x-axis. The y-intercept is where the line or whatever graph you're looking at crosses the y-axis. Now, because the intercepts occur on the axes, for the x-intercept, y will always be 0. X-intercept, y is always 0. Doesn't matter what the x-intercept is. The x-intercept could be 0, could be something else. The point is x-intercept, y will always be 0. For the y-intercept, it's the flip-flop, right? Regardless of what y is, the y-intercept's x-coordinate will always be 0. Okay, so let's do this first example together. We need to find the x and y intercepts, express the intercepts as ordered pairs, and then graph the line using the intercepts. So there's 2 methods that you can use to do that. The first method, which I prefer, is what I call the cover-up method. The second method is replace with 0 and solve method. I'm going to show you both methods for example 1. You can use whichever method you prefer after that. But for examples 2, 3, and so on, I'm going to do cover-up method just because that works best for me. Okay, so let's do it. If I want to find my intercepts, let's start with the x-intercept. We'll go in alphabetical order. Why not? I basically ignore y. I cover up y, pretend it's not there, and the equation that's resulting, this 5x equals 10, is what I need to solve to find my x-intercepts. You guys have already shown me your pros at solving equations. I already know, you know, that you have to divide both sides by 5, and we get x is 2. Now, what does that mean? That means when we go to graph our line, we're going to be on the x-axis at 2. And as an ordered pair, if we're on the x-axis at 2, y is always what? Y is always going to be 0. So our x-intercept occurs at 2, 0. To find the y-intercept, you guessed it, we're going to do the same thing, except this time we're going to cover up x. We want to find y. We don't care about x. We ignore this x business. And the equation that results, this 2y equals 10, is what we need to solve to get our y-intercept. So the y-intercept is going to occur at 5, and specifically as an ordered pair, if you're talking about the y-intercept, x will always be what? X will always be 0. All right. Now, if you don't like that method, you can use replace with 0 and solve, but what you're going to end up seeing is it's basically the same as the cover-up method. It just looks a little bit different. So if you want to find the x-intercept using this cover-up, using this replace with 0 and solve method, if you want to find the x-intercept, you set your y equal to 0. You plug 0 into this equation wherever you see a y and solve. Now what happens here? 2 times 0 is what? 0, right? This completely falls out. 2 times 0 completely falls out. 0 plus 5x is 5x. And what do you know? We're getting the same thing that we got over here doing the cover-up method. And I'm still getting my intercepts, but I think with the cover-up method it's a little bit faster. I don't know, what do you think? It's up to you. You can use whatever method you want. I'm not going to force you to use one method over another, and I'm not going to be offended if you like to use replace with 0 and solve. Okay, so our ordered pair is still going to be the same as we got before. It's going to be 2, 0. So to find the y-intercept, what do? we set what equal to 0? We set x equal to 0. We're going to replace this x with a 0. And solve for y. 5 times 0 is 0. 0 plus anything is that anything. In this case, our anything is 2y. Oh, isn't that nice? Divide both sides by 2. We get a nice number. 10 divided by 2 is 5. So what does that mean? Our y-intercept occurs at 0, 5. Y-intercept is 5. The x-coordinate is 0. Okay, that will always be true. No matter what y is, for the y-intercept, y could be anything, but x will always be 0. Okay, now let's graph this thing. X is to the right, y is to the sky. I need to get some tick marks going on here. 3, 4, 1, 2, 3. 1, 2, 3, 4. Okay, it is a sloppy graph, and I'm sorry about that, but it'll still get the job done. My x-intercept was at 2. My y-intercept was at 5. I'm going to plot the x-intercept on the x-axis at where? At 2. Place a dot on 2, but 1 point's not enough, right? Think of all the lines that could go through that 1 point. There's several. That's why we need another point to determine this unique line, its graph. My y-intercept is 5. That means on the y-axis, I'm going to have a dot on 5. So that's going to be up here. I have 2 points. Those 2 points are going to determine the graph of my line. Okay? This example is done. Please click on the next link to access example 2. Thank you.